Welcome to the Electronic Security Networking Technician Webinar Training, section number 7. The Electronic Security Networking Technician, or ESNT, Training and Certification Program is a complete training program for physical security technicians and personnel, people who are involved in the electronic security business of installing CCTV cameras, access control systems, intercoms, and the like onto IP networks, onto LANs and the internet. This program is administered by the ETA, the Electronic Technicians Association, who are a nonprofit organization that handles the certifications for over 1,000 different types of electronic certifications, with the ESNT program being one of them. To complete the ESNT training and to receive your certification, you must complete all 9 of the webinar sections, this being section number 7. You also must attend a one-day hands-on networking lab, and that's also where your written certification test is given and administered. These tests and these certification labs are run regionally around the country. You can check our website, www.slaytonsolutionsLTD.com, for certification classes and testing dates in your region, in your area. My name is Dave Ingebrigtsen. I'll be your instructor today. I'm ESNT certified. I'm certified fiber optic technician. I'm also Network Plus certified. I've been in the electronic security business for 33 years. And for the last 12 years, I've had my own company, Slayton Solutions Limited, where we provide independent, vendor-independent training in networking and fiber optics. Today's webinar, number 7, involves IP-enabled security devices. And this is where we're going to talk in detail about things like IP cameras, intercoms, access control panels, how we program them, how we connect them up to local networks and the internet. Now, we've talked about it in previous webinars, but here we really want to drive home the point that there are 4 things, I call them the 4 magic keys, that you need to know about any device that you want to program onto a local network and potentially so it's viewable or accessible over the internet. The 4 magic keys are the IP address, the subnet mask, the default gateway, and the TCP/IP port numbers. So if you had 10 cameras and you were going to install them in a customer's location, you would go to the IT department and say, I've got these 10 cameras. I need 4 sets of the magic keys. I need static IP addresses. Remember, our devices, whether it's an NVR, a DVR, an IP camera, a intercom, they're classified as servers, and they need static IP addresses. So you need static LAN IP addresses. You need the subnet mask that the customer is using on their network, assuming you're sharing the network with them. You need the default gateway, and you need the TCP/IP port numbers. And we've got port numbers plural there because some products require more than 1 port. Now, this configuration of the 4 magic keys, you will find it in every single device. Now, what's important to know is that different devices might call things by different names, but they will always have those 4 entry items: IP address, subnet mask, default gateway, and port number. Here you see on an Axis camera the screen that when you click the radio button that says obtain IP address via DHCP, then here comes the use the following IP address, and this happens to be defaulted. This is the default IP address of an Axis camera, 192.168.0.90. It's got the subnet mask, 255.255.255.0. That's a default Class C subnet mask. And then we have our default router address, which is 192.168.0.1. Now notice they call it the default router. This is an example where some manufacturers call the same programming field by a different name. I've seen the subnet mask called the subnet mask masking. I've seen the default router called the default gateway. I've seen it called the router address. So remember, there could be a little change in nomenclature of what they call these entries, but these entries will always be on the device somewhere. Now, all devices from the manufacturer, virtually all of them come with a defaulted IP address, and it's going to differ between manufacturers. It so happens that access cameras come with a default IP address of 192.168.0.90. That's the default address they use. Now you have to know what that default address is, because you're going to have to be able to go into the device and give it the proper IP address that it needs so it can work on the network you're going to connect it to. And to do that, you're going to have to take your netbook or laptop and you're going to have to program it. If you want to talk to this camera that's IP address 192.168.0.90, you are going to have to program your laptop or netbook so its IP address on its wired NIC card, assuming you're talking to it with a wired Cat5e cable, you're going to have to program your laptop or netbook to be 192.168.0. something besides 90, because you don't want to duplicate the IP address, and below 254 and higher than 1. And that, well, it could be 254 or lower and higher than 1, or 1 or higher. So you get the basic idea. Don't pick the same IP address as what's in the device, but it's got to match those first three groups if it's a Class C network that we're dealing with. And that's what we're going to be dealing with 95–96% of the time. Now here you see that in this access camera, there's a difference on a different screen than where the IP address is where their software TCP/IP ports are. Notice that down here they call it the HTTP port, and it's defaulted to port 80. This is important to remember. Most of our manufacturers of video devices, cameras, NVRs, DVRs, they're going to default their device to port 80, which is the default HTTP port. When you're on your computer and you type http://www.espn.com because you want to see the football scores, you're saying take me to port 80 on the ESPN server. That's what you're saying. That's what HTTP means when you put it in the address line. Okay? If you put FTP in the address line, you're saying take me to port 20. It's a separate issue. The deal here, though, is that all of our products from our manufacturers are typically going to be defaulted to port 80. You want to get off the defaults, and we recommend that you pick a number higher than 1600 because there are scanning softwares available that will scan a network and find all the open ports on it. And most of those scanning, when a hacker, when a hacker is looking for a target, he'll scan thousands of IP addresses, and usually he'll scan the first 1,500 ports. Remember, there's 65,535 ports. He'll scan the first 1,500 because that's usually where the action is, right? So we're going to practice what's called security through obscurity. We're going to pick a port number higher than 1,600 so that if somebody wants to find that open port, that device that faces the internet and will respond to an outside request or an outside communication, we're going to make them have to search all 65,000 ports, which takes a long time. They're going to get bored and go somewhere else. At least that's the hope. So here is where you change the port number. When you change the port number, you got to remember what you changed it to, because if you don't, you better remember how to default your product, whatever it is, camera, encoder, or DVR, NVR. You better know how to default that product back to its factory original settings, because you're going to have to start over if you forget the port number. Now, we've already talked some about the ports, but here's a slide that gives us a little more information. Those TCP/IP ports are there for common network. Some of them are used for common network services, like domain name service, and DHCP, and FTP, and HTTP. They use some standardized port numbers, like port 80, which is the Hypertext Transfer Protocol, or HTTP port. We should always change this port number. That's why it's in red on there. When you go to your bank or your online brokerage service and you see HTTPS in the address line of your computer, you're doing secure HTTP, or what's called secure socket layer, where the communication is encrypted. Okay, so that's the encrypted port for HTTPS. Now, what we have to do with these port numbers is we need to set them in the device, whatever the device is. We need to clear them through the firewall, and we need to forward them through the router if the device is to be accessed from over the internet, and if we want to allow that remote access through the internet. So here you see an example of how this is done. In the lower right hand side we've got a camera. We program the camera. It's on the local network with a local IP address of 192.168.1.3. It's hooked into an port 85. Now it's hooked into a network switch. On the other side, on the left, we've got a PC. It's 192.168.1.2. Got a PC, got a camera. Pretty small local network. Above that, on the left-hand side, you see a line. That line represents the interface between the local network and the internet. What sits between the local network and the internet? The router does. The router has two IP addresses, and then the router has the port forwarding in it that allows us to set the port forwarding to say, if anything comes knock, knock, knocking from the outside world, from the internet, comes knock, knock, knocking on port 85, I want you to forward that to IP address, the local IP address, 192.168.1.3, which is the camera's address. Remember, our routers have two IP addresses. Now let's take a look at a router for a second so that you'd see what's going on here. I'm going to Internet Explorer. I'm going to type in here once this thing wakes up. I'm going to get in here to the address line, and I'm going to put in 192.168.1.1. That's my router address. I get my username password challenge. I say OK. Now, first of all, if we look at the status of our router, you'll see that we have two IP addresses. We have our local network address, which is 192.168.1.1. Okay. So that's its local address. And then we have a router address. This is the side that faces the internet. It has an address of 172.16.1.34 with a default gateway of 172.16.0.1. Now ask yourself, are those public IP addresses? The answer is no. Those are Class B private addresses. And what that means is that between the router and the internet, there is another router, and that other router is the DSL adapter. You may remember from a previous webinar, we discussed the fact that the DSL adapters are often routers as well, as are some cable modems. So even in a small network like the one that I have in my house that has one internet connection, it goes from my computer to my network switch into my router. Then that router is connected to another router, which is the DSL adapter. So between the DSL adapter and the router, there's a network. A network can have two devices on it, a local area network. And this is a perfect example of that. So here you see it's the fact that there's the two IP addresses. Now let's look at applications in gaming. Here you see how my router is set up to allow the port forwarding. Now, the thing you've got to watch for when you're doing this in the real world is that different manufacturers will call this function by different names. Belkin calls it a virtual server, and there are other products that call this port forwarding or network address translation feature. They'll call it by different names, but it is the same thing, okay? And here's how you can tell what screen you want to go to. First of all, there's going to be a name, the application name, and that's a free-form field. You can put anything you want. Then there's going to be a range of ports. Now let's look at the top line. You've got the Joan cam, and the port number starts at 85 and it ends at 85. This happens to be a camera that only needs one port. So I start at 85 and I end at 85. There are some products, like some VoIP telephone adapters, that need consecutive, 4 or 5 consecutive ports open at the same time. But this camera doesn't need that. It only needs one. So we start at 85 and we end at 85. Now it'll ask you the protocol. What protocols do you want to allow forwarded to and from these ports? And there's TCP and UDP or both. Now I'm going to pick both because I may transmit JPEG images or I may transmit MPEG images. So I'll pick both kinds of protocols, so I'm good. What's the local IP address? In this case, it's 192.168.1.10, and it's enabled. I click the Enable button. So that's how I got this camera port forwarding onto the local network, or port forwarding over the internet. So now I can take Hang on one second. Let me do it this way. We'll open up another Internet Explorer. And you'll see here that I can go http://dave.shacknet.nu because I'm using dynamic DNS, port 85. Here comes the camera. It answers. So here I'm watching the camera. Oh, there's my wife putting on her headset. Here I am watching the camera over the internet, correct? Because that's an internet address. Now, I can also call a camera up with its local address. So I can reach the camera, I can go back into an Internet Explorer, and I can go http://192.168.1.10:85, and boom, here you see the username password from the same camera again. Okay? Now, the point here is that when you have changed the port number, and this is important to remember, when you've changed the port number on that camera, whether you now are accessing the camera from a computer on the local network or whether you are accessing it from the internet, either way now you will have to use the new port number for every communication, local or on the internet. You're going to need the colon and the 85. Otherwise, the camera will not talk to you. This is important to remember because if you forget it, what's going to happen is you're going to try to reach the camera with Internet Explorer or Firefox. You're going to put in the IP address. The camera won't answer. Then you're going to ping it, which we'll talk about in the troubleshooting section, which is a common networking testing tool. You're going to ping it, and the camera's going to respond to the ping. And you're going to say, wait a minute, it responds to the ping, but I can't get the camera to give me username password challenge. It won't open up for me. What's my problem? Your problem is you forgot to use the port number. So remember, when you change the port number, you've got to use it every single time that you or the customer communicates to that device. Now, here you see a slightly different illustration, but it talks about the same thing, okay? When we have our local access, we're going to use the local IP address and the port number. When we want to call it over the internet, we're going to use the internet address, in this case 45.23.45.123:85. We're going to use the internet or public IP address of that DSL adapter or cable modem and the port number. And that's going to bring us to the camera. So we've got two ways now to get to the camera. And, you know, we don't have to have just one camera device. We can have multiple devices. Remember, if you have multiple devices, you must use unique local IP addresses and you must use unique port numbers. I will point one other thing out here before we move along. And let me go to this port range forward screen. Here you see, I want you to look down to the third, fourth, and fifth entry here. This is my NUO 2040 NVR. This device requires 3 ports. One for communication, for calling it up, one port to give you live video, and one port to give you recorded video. So they're ports 80. It was defaulted to port 80 for the communication. I changed that to 8010. There's port 5150 and port 5160. Notice that I have forwarded all 3 ports, and I used both for the protocol selections, and they're all forwarded to the same IP address, 1.55. You see how that's listed 3 times, and they're all enabled. So you have got to know your product. In this case, this NUO NVR needs 3 ports forwarded. So that's what you got to do. And you're going to have to open those 3 ports in the firewall of the DSL adapter or cable modem so that it allows the traffic in and out those port numbers to that device on the local network. So know your equipment. Make sure that some devices need more than 1 port, well, you got to set up and port forward and clear the firewall for as many ports as that device needs to make it work. Very good. Now, we're here, so we'll go here. Talking about UDP and TCP for video. We talked at an earlier webinar about UDP and TCP. UDP is that transmission that requires no receipts. It is generally used for communications that are supposed to be real-time, like VoIP telephone calls. UDP is typically used for some compression protocols that are commonly used in our business, such as MPEG-4 and H.264. It has a smaller and simpler address header, and it doesn't require receipts. In comparison, there is TCP communication, which is often used in inexpensive cameras, and it's also used in a lot of the megapixel cameras as we speak today. Now, the issue with TCP is it increases our reliability, but it increases latency and it increases the bandwidth requirement, both for storage and for the bandwidth of live video transmission. So when you're looking at a product and you're saying, which one am I going to use? And let's be frank here. If you're putting one camera in Joe's shoe store, it really doesn't matter what camera it is, and it really doesn't matter that much how much bandwidth it uses, because it's only one camera. And you're hooking it up, and Joe wants to be able to watch his one shoe store from his house. You've got a wide open field of selection there in terms of device and compression protocols that you might use. If, though, you're putting 25 cameras or 50 cameras on a customer's shared network, this is where the protocol you use or the compression format you use and the protocol it uses to transmit becomes an important thing, because we want to give them the best possible pictures without excessively using the bandwidth. And remember that our issue is going to be with video transmitters. It's not going to be with alarm transmitters. It's not going to be with intercoms, and it's not going to be with access control panels. It's going to be with video, because typically when we put a camera up, we want that camera to be recorded 24/7. We want the video recorded, therefore there's going to be a constant stream of video on the network. So here you see the difference between the TCP and the UDP address header. Notice that there's a lot more information required for the TCP header. Makes the packets bigger, makes them longer, right? More addressing information. Less addressing information in the UDP header, that means it makes the packets smaller. So not only are we going to be lower bandwidth because we're not asking for receipts, but we're lower bandwidth because our address information is less. So now we've got a couple of ways that we can allow multiple users to receive video and or audio simultaneously over a network. So we're talking now about 2 or more people want to view a camera at the same time, or they want to view a camera and get the audio from the camera at the same time. So we want to talk about unicasting and multicasting and how this can affect the bandwidth of a network and what some of your options are when you're setting up a larger system, an enterprise level system. And one of those options is multicasting, which we're going to focus on here in just a couple of minutes. But first, let's understand what a unicast is. A unicast is a one-to-one situation. We've got a user on the right-hand side sitting at his computer. He is communicating to a camera over on the left-hand side that's hooked up to a video encoder that's pushing 200 kilobits per second of video through the network, and that's a one-to-one connection. That's easy to understand. Now, we can have multiple users. If we do have multiple users, you'll see with most IP cameras, from the major manufacturers, the Axis, the Bosches, the Sonys, the Panasonics, their cameras can have 8, 12, 15 user passwords. And all those people could potentially communicate to the camera at the exact same time. What's the camera going to do? The camera is going to set up a separate stream to each receiving device. And each one is going to consume the same amount of bandwidth. So what you end up with is a situation like this, where if we've got 5 users calling up that one video encoder simultaneously, this particular video encoder is going to put out five 200 kilobit video feeds. It's going to set up one for each one. So you see that we greatly increased the bandwidth requirement in the local network, or at least in that segment of the local network, because we've got those 5 video streams that are going through it. Now, one of the things we can do that's mentioned on this slide is that there are some cameras from some higher end manufacturers that allow you to set up multiple different video streams. Some, you could be streaming 5 frames per second for recording, and it's 15 frames a second for live view. There's different ways you can do that, but there are some products that will do that, allow you to set up different bandwidth levels for different kinds of users. Now, with multicasting, this is where we are going to have the network itself, the routers and switches in a large network, and this is only going to be in a large network. In a large network, enterprise level, the network itself will do the distribution of the audio or video. Now, what's key here is that if you want to do multicasting, every device that's in the multicast path between the device, say the camera, and each viewer, every device must be what we call IGMP, or Internet Group Management Protocol, enabled. It must have that capability. If it doesn't have that capability, it will not work. Okay? And what we end up doing is setting up an internal IP address. You may remember from a previous webinar where we talked about the classes of IP addresses, class A, B, C, and D. The D addresses are the multicast addresses. We're going to use one of those multicast addresses as an internal address on the network, and authorized users are going to communicate to that internal IP address, and they're going to receive, if they are an authorized user, they're going to receive the video or audio stream. And what this does is reduces our bandwidth requirements in the network. So here you see what multicast is going to look like in one example. Our VideoJet video encoder is putting out a 200 kilobit video stream. It goes into the network one time, and then the network distributes it to the authorized users. And we could have hundreds of users viewing the same video stream. What's important to note here, though, is that whatever video stream we set for the multicast, it's going to be exactly the same for every single user. We're not going to be able to vary the frame rate or the resolution. It's going to be set for the multicast. It's going to be set one way, and then every authorized user who calls in is going to get the video in the exact same way in terms of frame rate and in terms of resolution. So here you see a graphic example. On the top, we've got a unicast communication with 3 users, and you see if that camera's putting out 3 megabits, because it's a megapixel camera, and it's putting out 3 megabits for each video stream. Well, there they go, and you see that in part of the network we're going to be using a lot of the bandwidth to transmit the video, where in the lower section you see the same camera performing a multicast communication, where only one 3 megabit video stream comes out of it, and then the network distributes it through its routers and switches. Multicast is going to use UDP. Makes sense, because we want the fastest transmission time, we want the lowest latency, we want to be as close to real time as we can. And then with UDP that there are no confirmation packets or acknowledged packets being sent, from the receiver to the transmitting device. Multicast also uses a protocol called RTP, or Real-Time Transport Protocol. It's included with the UDP packets. It sets up the packet number, sequencing, and timing so that the receiver knows where this packet fits in case a packet shows up, it got out of line somewhere and it ended up showing up later than it was supposed to. Multicast works by setting up that internal IP address we discussed. And it's going to be one of those Class D addresses that start at 224. And specific port numbers are going to be set up for the multicast communications. Now, this is, again, I emphasize this because this is important. If you want to do multicasting, your network switches and your routers must be IGMP, Internet Group Management Protocol, enabled. You're going to find this in specific Cisco and major league enterprise level products. Big routers, big switches from big companies at the enterprise level are going to have this capability in them. Now here you see the multicast setup in the camera. You have to tell the camera or video encoder or whatever device it is, you're going to multicast. So you see where it's got a port range, and you see here it tells you what ports you can use for the multicast. And it tells you can either use port 0 or you can use a port from 1024 up to 65,534 and even values only. Same for the audio port, because a lot of these Axis cameras or higher end cameras have audio capability as well. You can plug a microphone into them. So you can have audio and video being multicast out. Notice it's got the video address and it's defaulted to 239, 233, 113, 137. It's just an address. But you're going to select a multicast address for this particular camera, and it's going to be an internal address in the network that then the users are going to access that address and the port number, and inside the network switches and inside the router there's going to be one of them that's going to be feeding out the video streams to the users, or feeding it through the switch fabric to the authorized user that wants to see the video or wants to hear the audio, or both. Now, our vendors make encoders for single 4 and 8 camera that could be MPEG 2 or 4 or H.264 that are going to encode analog cameras. So we can take analog cameras, we can put them on the network, and we can multicast them. Our encoders are going to have programming fields for the multicasting as well. And we can also have some manufacturers, interestingly enough, also make decoders. This is pretty cool, because what you can do is you can stream the video through the network and then have it aimed at a decoder that's going to take the IP video stream and turn it back into an RGB TV signal, so it can be put up onto a big, 60-inch regular, television set. So we don't have to quit selling those big monitors that we love to sell. If you want to put a 60-inch flat screen on the guy's wall and you want to put the security cameras on it, there are manufacturers who make decoders for their products. One of the things you're going to find when you get into this is that very often, if you want to get fancy or do something that's relatively sophisticated, you're going to have to use the products from the same vendor on both ends. For example, the Bosch makes a decoder for their cameras and their video encoders, but it only works with Bosch cameras. It doesn't work with Panasonic, doesn't work with Axis, it works with their cameras. So that's something to keep in mind. You may have to have some uniformity in the products that are being selected. So why would we want to use multicasting? Well, it lowers our bandwidth requirements. We can have thousands of users of simultaneous viewers if the network will support it. And we've got some new service possibilities. What are some of our considerations for multicasting? Well, your camera or your video encoder has to support multicasting. Every device on the network must support multicasting. The routers and switches in a wide area network, or if it's just a LAN, the switches in the LAN must support multicasting. You won't find multicast support in a $50 D-Link box. It's not there. It's going to be your customer. It's going to be at the enterprise level. It's going to be a 19-inch rack mount switch. It's going to be expensive hardware that does that IGMP, that's capable of doing that allows the multicasting to happen. Multicasting doesn't happen over the internet. Okay, it just generally will not work. So you just can't do it. I've read some papers that say that if one computer is slow, that could slow down the communication for others. There are firewall issues, and also understand this: multicasting is for live video only. Let me repeat that. Multicasting works for live video and live audio only. It's not for forensic, let's look at what happened yesterday. That's not going to happen with multicasting. Multicasting gives us live video now, not forensic video, not recorded video. So that's a consideration. And we may have firewall issues with some of the viewing computers. That can happen with any physical security device that we hook up. There may be software firewall issues. There may be hardware firewall issues that have to be negotiated, or the firewall has to be programmed to allow that communication, that video stream, that audio stream to go through. So now let's talk for a few moments about video compression. It's important to understand, it's important to understand that all video that goes through a network must be compressed in one format or another. If we had uncompressed 30 frames per second, 640 by 480 video, the video bandwidth requirement would be over 150 megabits per second. It would exceed what we could push through a Cat5e cable, and it would also make storage completely unrealistic. It's way too much to store. To store 150 megabits per second of video is just, you can't do it. They don't make disk drives that big. So what do we have to do? We have to compress the video. And that video compression it's mathematic algorithms, and if you want the details on video compression, you can read my first book, which is we talked about in the end of the other webinars. There's a big chapter about the math involved, where basically it removes redundancies and extraneous material and reduces the file sizes. By reducing the file sizes of the video, and also, by the way, audio is also compressed. When you are on a VoIP telephone call, your audio is compressed as well. But we'll stick with the video discussion for now. It reduces the file sizes for transferring through the network, so the packet sizes are smaller, and also for storage. If they're smaller going through the network, they're smaller to store. So that makes things better. Now, so what happens when we put up an IP camera and we program it properly, we put the 4 magic keys in, we hook it up to the local network? What's it going to do? The light is going to pass through the lens, and it's going to be digitized. Then inside the IP camera, there is a processor that is going to compress the video using one of the common compression methods that we're going to talk about in just a minute. And it sends the compressed video packets out through the internet, or pardon me, through the local network, possibly through the internet. And then over here on the right-hand side, we've got the viewer. The viewer wants to watch the video on his or her PC. Now, what I want to point out here is, while the camera compresses the video, the viewing computer must uncompress the video. And sometimes, even though you may access the camera, let's say you're the viewer, and you access the camera with Internet Explorer. Let's say you've hooked up an Axis camera, and you're calling it for the first time from your desktop PC. If your desktop, the camera's you're going to put in the IP address, port number. It's going to ask you the username, password. You're going to put that in. Screen's going to pop up, and if your camera doesn't have the right viewing software, the Axis camera is going to prompt the viewer and say, hey, look, if you want to see this in MPEG-4, you need to download the MPEG-4 viewer, which is the software is in the camera. So you click yes, the camera will download to your PC a small bit of software, what they call an applet, that will allow the viewing of that particular Axis camera on your computer. You only have to do that one time, as long as you're using the same computer, and as long as your computer hasn't crashed and you had to wipe the hard drive and start over. You do it one time, then you can always call that camera and the video is going to pop right up for you. So understand that what's going through the network is compressed video, and what is viewed, what reaches your computer is compressed video, your PC, your laptop, and then your PC or laptop or netbook must decompress the video to bring it up to make it video again. So there's a compression and decompression process. Now, the two kinds of compression that are commonly used in our industry are JPEG and MPEG, and let's talk about what they are. JPEG is Joint Picture Experts Group. The files are saved as .jpg. In a JPEG video transmission, which is often labeled M or motion JPEG. Motion JPEG video coming to your computer to view it. Every image that's transmitted is a whole and complete picture of whatever the camera is seeing at that moment in time. So if you've got that camera set to transmit 15 frames a second, that's what it's doing. It's sending 15 whole and complete pictures. Now, JPEG is also used commonly in our digital snapshot cameras. When you're taking pictures of the kids and then you download them into your computer, what do they store as? .jpg. Those pictures are also compressed, and they're compressed using JPEG. Now, JPEG is often used in low-cost and megapixel cameras. In fact, virtually all IP cameras that I've looked at and worked with offer a flavor of MJPEG or JPEG. The reason primarily is that JPEG is a free technology. It doesn't require a license. You don't have to pay to use JPEG, so everybody will put it in their cameras because, hey, it's free, right? And it works. Now, the other kind of compression is called MPEG, or Motion Picture Experts Group, and this is, you can consider, a higher level of compression. The way MPEG works is, let's look at an example where you're transmitting 15 frames a second. What does MPEG do? Let's start with the timeline at 0 and start transmitting video. The first frame that's transmitted is what's called an iframe. It is a full and complete picture. It's a JPEG picture is really what it is. It's a full and complete picture of whatever the camera is seeing. Then after that, there's going to be a string of P frames, or predictive frames. These frames they're also called partial frames. But the P frame shows you the changes in the scene from the previous iframe. So back to our example, if we're transmitting 15 frames a second, the first frame is going to be an iframe, a complete picture. Then I'm going to have a string of 14 P frames. Then I'm going to get another iframe, 14 P frames, another iframe, 14 P frames. Now, because we are only sending one whole picture every second, we've reduced our bandwidth requirement. Another thing to consider is that let's say a camera is in a room and there's no people in the room, there's no movement, nothing changes. Do you see that the P frames will be very, very small? There's very little data in them because there's very little change in the picture over that 1 second time frame. So we get very small P frames if there's not a lot of movement. If there is a lot of movement, the P frames can be substantially larger sized files because there's more movement to send. Now, some manufacturers, and this is where we need standards in our business and we don't have them yet, but some manufacturers will use what's called a B frame, or a bidirectional frame. That's another whole frame that's put at the end of a block of frames, which is called a group of pictures, so that it allows you to watch the video in reverse. Now, you'll see this sometimes. You can actually see this sometimes if you take a movie on a DVD and try to watch it in reverse, and it just goes all blocky and stuff. Well, they're not using a bidirectional frame to allow reverse viewing, right? So there will always be the iframes, there will always be the P frames. Occasionally, sometimes you'll have the B frames. This is a manufacturer selection. And what happens, fortunately, unfortunately, but it's a fact of life, our manufacturers will take the MPEG 4, the Motion JPEG, the H.264, and some of them will tweak it so that it makes their products more proprietary. There is a movement afoot to standardize how this is done, but it has not happened as of this date in late 2010. Now let's talk about some of the MPEG compression options. MPEG, by the way, is a licensed technology. This is why you find MPEG compression in higher cost cameras, in the mainstream cameras, the Sonys, the Honeywells, the Panasonics, the Axis cameras. They're going to include a flavor of MPEG, and they're paying a license fee for it. MPEG 2 is the DVD compression. We don't usually use this in our industry. It requires a minimum of 1 megabit of bandwidth, which is kind of stout, and it's always going to be 30 frames a second. MPEG 4 was very popular for a while because it provided adjustments. You could have a reduced frame rate, okay, so you could have less frames per second, and you could adjust the bandwidth from 50 kilobits to 4 megabits, so you could change the bandwidth. And you know, if you can do something at 50 kilobits, that's going to come to a customer's iPhone. That's dial-up speed, so we can really lower the bandwidth. Remember, when we lower the bandwidth, we're going to reduce the frames per second. The image quality is not going to be that great, but we could get images at a bandwidth as low as 50 kilobits per second. Now, the most popular type of compression that is used in middle to high-end cameras these days is what's called H.264. It's also known as MPEG 4 AVC, Advanced Video Encoding. I've also seen it called MPEG 10. but it is a flavor of MPEG. It gives us DVD quality video at under 1 megabit per second. It requires greater processing power in the camera and encoder, and it requires greater decompressing power in the viewing computer or decoder. It really reduces the bandwidth though. Now, we need to talk about a couple things here. One is that if a camera is looking at an image, its field of view, where there's going to be a lot of activity, say it's a train station or a bus station, an L train stop in Chicago or a subway stop in New York, where there's people there all the time, these higher level compression formats will reduce the bandwidth when compared to motion JPEG, but in some cases it won't reduce it a whole lot just because there's a lot of movement in that screen. The second item to note is that when you have a camera that is outdoors, it's a day-night camera, when it gets dark, it is harder for the camera to see things, and our bandwidth will go up dramatically when we have a dark image versus a well-lit image. So this is something you have to consider in your calculations of the amount of storage you're going to need. If it's an outdoor camera and it's going to be in the dark and it's not well lit, well, it's going to require maybe 50% more bandwidth than it would during the day. So, but H.264 is the way our industry is going because it gives us the best possible images with the lowest possible bandwidth. Now, another thing that's coming to our industry and is here now for manufacturers like Axis are high-def IP cameras. And the definition of high definition is the camera is going to output a 1080i HD 30 frames a second, just like like HD TV that you're watching at home. This is going to be a real breakthrough for our industry, and it's already here. I've tested Axis cameras with HD, and you can get 30 frames a second at less than 1 megabit per second of bandwidth, and they're really an excellent quality image. So this is where our industry is going to go. The prices of these products will reduce, and then that's where we're going to be in terms of giving our customer the best possible CCTV system. It's going to be a networked system because we're only going to get this high def, and we're only going to get these megapixel cameras with our IP cameras. Now, another feature that's available in networks is power over Ethernet. PoE, as it's called, is a really attractive technology for us to use because it makes our devices, our door locks, our access control panels, our cameras, our video encoders, it can make them one cable devices. What do we do a lot of the times in our industry? If you talk to guys in the business and they tell the truth, you ask them, well, aren't we really wire pullers? Isn't that really what we do? And the answer is, yeah, a lot of the labor goes into pulling wire. Well, isn't it better to pull one cable than it is to pull 2 or 3 or 4? We can pull one cable now to a camera location, and on that cable we can get the connectivity to it with Ethernet. We can get the power to it, and now with the new standard, we've got enough power to run the pan, tilt, and zoom if it is a mechanical pan, tilt, and zoom camera, and it fits in the 25 watt maximum that's available. I'm a little ahead of myself. Let's talk about the standards first. The PoE standards are standardized by the IEEE. They are the 802.3AF and the 802.3AT standards. They provide 48 volts DC, that's important to remember, and the AF standard provides 12.95 watts. The AT standard provides up to 25 watts, and it works on Cat5e, Cat6, and Cat7 copper cable. Should be obvious to you that you can't do PoE over fiber because there's no metal. It's not going to conduct electricity. So these are standardized. If you pick up an Axis camera and you flip it over and you look at it and it is a PoE camera, it's going to be labeled 802.3AF or 802.3AT compliant, right? So you're going to know that it's built to the standards. And our manufacturers now, the majors, the Sonys, the Samsungs, the Panasonics, the Axis, the Honeywells, they're building PoE into their products into their middle and high-end cameras as a standard offering. So it's there. It's in the product already. So we're going to come back to this slide in a second. What we want to talk about is how do we get the PoE from the network telecom closet out to our device. Now, in many cases at the enterprise level, our customers have already purchased PoE-enabled switches. Cisco has sold over 100 million PoE switch ports. I mean, everybody's buying these things. Why? Because they want those VoIP telephones. And remember now, when we take our telephone and we make it VoIP, well, it's a network appliance, and everything needs power, right? Everything's got to be powered in one form or another. And we want to centrally power our telephones, because what happens if there's a power failure and your telephone is powered from a transformer on the wall? Well, your phone is dead. You can't dial 911. So it becomes a life safety issue. So when we have our PoE-enabled switch hooked up to a UPS in the telecom closet, and then we've got our VoIP telephones hooked up to that, now we've got phone service even if the main power has died, at least for some limited amount of time. In this configuration, this is called an N-span PoE switch. Now we'll flip back to here and talk about intelligent discovery. What PoE does when, you might be asking yourself, well, gee, Dave, that sounds pretty good, but what happens when I plug my computer, just a standard computer, into the switch? Is the switch going to blow up my NIC card because it's going to hit it with 48 volts DC? And the answer is no. What PoE uses is what's called intelligent discovery. When you plug that device in to the switch port, the PoE power will start to be applied, and the PoE device, the power sourcing device, it's looking for a 25K resistor at the other end. If it sees the 25K resistor, then it says, you're a PoE device. I'm going to give you the availability, and here you see the classes of availability in 802.3 AF, up to 12.95 watts of power. So here you see our power sourcing equipment. If the PoE power sourcing equipment starts to feed out the voltage and it doesn't see the 25K resistor, the PoE, the power sourcing equipment will drop the power off of that port. It'll say, you're not a PoE device, I'm not going to give you the current. That's how PoE keeps from blowing stuff up. It doesn't want the PoE current, doesn't need that power. So we can either plug into a PoE-enabled switch, or we can use what's called a mid-span power hub. Let's say that you want to install 6 cameras on your customer's network, and you want to be on the shared network, and the customer has no PoE in his switches. You can go to a distributor, you can buy an 8-port PoE mid-span hub, and you would cable it just as you see illustrated here. You'd go from the Ethernet switch with a short jumper cable to the mid-span power hub, and then that mid-span power hub is hooked up to the UPS for primary power, and then it's going to power up to 8 of our devices in the example that we're discussing. Now, it's important to know that in our Cat5e cable, we've got 4 pairs. When PoE comes out of the network switch, it works on the orange and green pair, the same 2 pairs that is used for 10100 Ethernet. When it comes out of a mid-span hub, it uses the brown and blue pairs. But here's what's important. The PoE-enabled device, field device, the camera, the Wi-Fi access point, the VoIP phone, if it's built to the standards, and they all are, then it doesn't care if the power comes on the blue and brown pairs or if it comes on the orange and green pairs. It doesn't care. It'll take it. This is one of the real beautiful things about PoE, is that you don't have to flip any dip switches or do any programming in the device to make it accept the PoE power properly. You plug it in and it works. Now, there's a couple things I want you to remember. One of them is you want to make sure you use high-quality cable and good quality connectors if you're doing PoE out to your cameras, access control boxes, intercoms, and other physical security equipment. Number 2, if you're doing PoE, do not exceed the 100 meters maximum from the telecom closet or from the network switch out to the device. Make sure you stay within the distance that's available. Number 3, make sure that you power your device. You need to select what power source you're going to use for your device. Let's say it's a camera, and maybe the camera came with a plug-in transformer, or maybe the camera says it can take 24-volt AC or DC, or it can take PoE. Well, you need to pick the power source and only use one. You can't power it with multiple power sources. You'll blow it up. So don't do that. If you're going to do PoE, do PoE. If you're going to do a separate power supply with 24 volt AC or DC, do that. It's going to require extra cables, but only use one power source, okay? And the fourth thing I want you to remember is if you do use mid-span hubs, you need to carefully read the specification sheets, because there's some manufacturers, not all, but some. Let's say you've got an 8-port mid-span hub and it's 802.3 AF. It's the old standard. So it's 13 watts per channel, or 13 watts of power availability, 12.95, 13 watts, right? And you've got 8 ports. Well, 8 times 13 is 104 watts of power. But what you might see in the specifications for that mid-span power hub is that the maximum amount you can draw from that power hub is 75 or 80 watts. Do you see that the maximum you can draw from the mid-span power hub is less than the potential that could be drawn if you max out the current on every one of those 8 ports? So you have to look at your field device, your cameras, your encoders, whatever you're using. You have to look at the specs on those, and you have to say, okay, these cameras draw, I'm putting in 8 cameras and they draw 7 watts apiece. 8 times 7 is, I don't know, 56, right? Something like that. And now you know that you're not going to overdraw the maximum amount of power that mid-span power hub can put out. So watch for that, okay? Because it's something that can get you if you're not thinking about it. Now, when we're setting up our cameras, we need to limit the bandwidth that we're going to use. And we need to do this for a couple reasons. One is the IT people are going to be concerned about the amount of bandwidth. And remember that the bandwidth issue is a multiplier. If we're putting in 1 camera, that's no big deal. But if we're putting in 25 or 50 cameras, it is a big deal. And we want to make sure, or do our best, if we're on a shared network, that we're not interfering with or slowing down enterprise network traffic. Because let's be honest, does the IT guy care about your physical security system? No, not really. He or she cares about their workers and how fast their network works, and they're worried about the security of their data and the security of their network. They're not that worried about your cameras and such. So if we are sharing the network, we've got to limit the bandwidth, and we need to know how to do that. And every device we install will have specific options and methods by which to limit the bandwidth. Now, the first thing you can do, and the easiest thing you can do to limit the bandwidth, is to reduce the frames per second that are transmitted. Now, this requires a certain leap of faith, because most security people I know, alarm people, physical security professionals, when you talk to them about CCTV and you talk to them about video, they say, video, that's 30 frames a second. It has to be 30 frames a second. Well, we make our lives difficult, and we greatly increase the bandwidth requirement if we leave it at 30 frames a second. Generally, we're going to set up on the local network, we're going to set our video encoders or cameras so they give 15 frames per second maximum over the local network. That's going to give your viewer a quality viewing and recording experience. It's going to look good. And when we cut the frame rate in half, we cut the bandwidth in half. It's that simple. And we need to manage our customers' expectations, because one of the things that's important for your customer to understand and should be demonstrated to them is that they can get 15 frames a second over the local network. That's not a problem. But viewing that same camera or NVR from over the internet, they're going to get 3 to 5 frames a second tops, because internet connections, as we described in earlier webinars, are much smaller pipes than the pipes in the local network. So we're going to get 3 to 5 frames per second tops on an internet connection. They need to know that. And we need to, if we increase the amount of compression, that's going to lower the resolution of the picture. It's going to make the frame sizes smaller. It's going to reduce the storage requirement, but it's also going to lower the quality of the image. How bad do they want the pictures to be, or how good do they want the pictures to be? this is something that we've got to demonstrate to them and say, well, we can set it like this, we can set it like that, and this is the bandwidth that's going to be required. Now here you see on an Axis camera where you can set up the bandwidth, you're setting up the resolution, and the resolution you set will have a direct effect on how much bandwidth is required regardless of the video compression that you use. You're going to have a separate setting for the video compression, and you're going to have a separate setting for the resolution of the camera. In fact, you can see the compression setting here. You can't really see it because the box is pulled down, but the compression setting is going to be right here, and it's going to be a percentage issue. The higher we set the compression, the smaller the images are, the smaller the file sizes are, and the smaller the storage will be, but the worse the quality will be. Now, the good news is that the major manufacturers, the Axises, the Bosches, the Honeywells, the Sonys, they have software that's available that's a free download that you can do your bandwidth calculations for specific products based on how you set the compression, how you set the resolution, lighting situations, etc. And you can then use their software to calculate how much hard drive space you need to store the video for. You know, the customer wants to store it for a month, or the customer wants to store it for 2 weeks. Okay, fine. Let's work on that, and let's see what we can do to how are we going to have to set our devices in terms of resolution and compression to get that amount of storage in the hard drives that we've selected. Now here is a screen from a vendor, Bosch. This happens to be an MPEG-4 stream setting, and one of the nice things about their product is they give you a target data rate and a maximum data rate. So the target data rate for this particular camera or encoder is 500 kilobits per second. Maximum data rate is 1,000 kilobits per second. So this is the kind of product that you need to know about, because if you're sitting with the IT person and you're saying, okay, we're going to put these 25 cameras on your network, and the IT person says, well, how much bandwidth is that going to take? You can look at the IT person and say, how much will you give me? Well, you can have 1 megabit per camera. Okay, no problem, sir, because the cameras I'm using can be set so that their maximum data rate will be exactly that, 1,000 kilobits or 1 megabit per second. So, and these are adjustable. So this is something to look for in a higher end product. Lower end cameras, you're not going to get this option. Generally in the lower end cameras, all you'll get is a frame rate and possibly a compression setting. You typically won't get this kind of settings, which we would call a granular setting for the bandwidth. Now, we can talk about quality of service. Here we're talking about what happens if we're losing data packets in a video feed. In our local network, we shouldn't lose any packets, but over the internet, we will lose packets. With quality of service tools that are available in some of the network switches, which we discussed in a previous webinar, we could prioritize, say that our camera's transmitting in UDP, we could prioritize that the UDP packets get higher priority than TCP packets, which would increase the quality of the viewed video and of the recorded video. So here's what happens when you don't get complete information from, you're losing some of the packets, and you get a situation like this where you get, a partial picture like you see in the upper right hand side, and then you get what is basically garbage on the two left hand side ones, and then the lower right hand side one is one that just can't connect at all. So this is what the effects of lost data can be on viewed and stored video. Obviously, if you're storing what you see on the left hand side here, is you're storing garbage. It's not going to be good for anybody. Now, megapixel cameras are really the stars of the IP video surveillance world. Megapixel camera simply means millions of pixels. A megapixel camera gives us many advantages over a standard resolution camera. The image itself is larger, and we have excellent pictures for video storage and analysis. One camera properly placed could take the place of 2 or 3 other cameras, so it actually could reduce the cost of the installation. They're going to have more and varied video setting options. One of the things you get in megapixel cameras is you get digital pan, tilt, and zoom usually. So you can actually zoom in on the images either live or forensically. You can zoom in on the images because you've got those millions of pixels. So you can zoom in and read that license plate number. You can zoom in and look at that person's face. Now, when you think about using megapixel cameras, you don't have to use them in every installation, or in an installation. They don't have to all be megapixel cameras. You might have a circumstance where you tell the customer, look, we'll put a megapixel camera here on the front door so you can see the faces of people coming in. We'll put a megapixel camera here in the loading dock so you can see the trucks come in. You can read their license plates. You can see the people unloading and loading the stuff, the products on and off the trucks. So a couple of properly placed megapixel cameras is the right way to go, because megapixel cameras cost more than the IP standard resolution cameras. So there's a higher cost, but that cost is coming down. And we will see megapixel cameras, you know, the ones that are $1,500 wholesale nowadays will be $1,000 in a year, and a year after that they'll be $600, and they'll drop in price like everything else does that's technology. There may be an issue with, in terms of a disadvantage of megapixel cameras, is the bandwidth. But nowadays, most of the megapixel cameras, although when they're set to transmit in a motion JPEG, they will require 8 to 12 megabits per second of bandwidth, and that's pretty big, right? But remember, we can reduce that by cutting the frame rate. And there are also manufacturers now that are including H.264 compression with their megapixel cameras, giving us the best of both worlds. Really big, really high quality images with a reduced bandwidth requirement. But even with H.264, you could see your typical megapixel video bandwidth might be 4 to 8 megabits per second. So it is going to be a healthy sized video bandwidth. But remember, you don't have to use them in every circumstance, and also it's the megapixel camera that gives the best possible image. And I want to emphasize this, because remember that I want you to think about something. Most of the time, our customers are not watching live video feeds. The video that the surveillance cameras we install, we record them, right? Why do we record them? So that there's forensic data. You can watch what happened yesterday. And if you want to watch what happened yesterday, don't you want to give the customer the best possible viewing and analysis? You know, the better the image is, the more that you can see, the better the situation is. So there's a place for megapixel cameras. There's going to be a big place for them. This is going to take us into what I call HD IP CCTV. This is where we're going to be able to show our customers a quality difference between IP cameras and standard analog coax cabled cameras. Megapixel cameras are better. Better image, better pictures, better forensic quality. And that's what our customers need. Now, this is the end of Section 7 of the ESNT webinar training series presented by Slayton Solutions. Remember that there are training and reference manuals available. You can get the Technician's Guide to Networking for Security Systems. That's my first book. My second book, The Technician's Guide to Networking for Security Systems, Enterprise Solutions, is a book about high-end troubleshooting and that sort of thing. Both of these books are available at ADI, or you can get them at my website, SlaytonSolutionsLTD.com. Now, you can order your ESNT study guide, or that may be where you got this webinar from. But in your study guide, you're going to have PDFs of all the webinar sections. You're going to have the recorded webinars so you can watch them again if you wish, as many times as you want. And there's going to be a quiz for each section with answers. And you should take those quizzes as you're working through these webinar sections, so you make sure that you've absorbed the knowledge you need so that you can come to the one-day lab where we do network testing and network troubleshooting, and we provide the written ESNT test. And you can secure your future with the ESNT training and certification program. I thank you for watching this webinar, and we will go on to the next section.